All right, welcome back, part 2. Time value of money. Ooh, I'm in the way. There you go. $1 today is worth more than $1 tomorrow because today's dollar could earn interest. All right. We have to have a whole conversation about time value of money before we can even start talking about the present value method. Because you have to have the fundamental understanding of what the time value of money is before we can go there. Okay, so think about this. $1 today is worth more than $1 tomorrow because today's dollar can earn interest. Different way of thinking about it. If you had $1 today, do you expect that you'd be able to buy more with that dollar today than maybe you would a few years out? Okay, so a different way of looking at it. All right, so let's get into math a little bit and showing you how to use these tables. Now there's a ton of different ways. Your calculators can very often do time value, can do present value calculations and whatnot, but I'm going to show you the way that I want to show you, which is using the tables in the book. All right, there's purely mathematical ways of doing it. We're going to use tables. Okay, assume that you have $1. Let's look at the present value of 1. Assume that you have $1 that you're investing with a 12% interest rate, and that interest is compounding annually. So let's say you put $1 away. Here we go, on year 1. That dollar is going to then earn 12 cents, or 12%. By the way, 12% is an amazing interest rate. If you can find anyone who's invested, well, I was going to say anybody legal who's using a 12% interest rate, like that you're earning it, that's amazing. Go for it. Legal being the key word there. Okay, so if we did the math on that, that's $1 times 12%, right? That's 12 cents. If we do it times 1.12, then you have the full amount of $1.12, but here we go. The idea is you get 12 cents, so now you've got $1.12. And compounding annually means you're leaving your interest in there to continue to earn interest. So now instead of $1, you have $1.12. $1.12 at 12%, that's the compounding part, after another year is 13 cents, 13.5. Okay, I should probably minimize that. Okay, so what I've done is I've done this through 5 years. So you've got $1.12 plus the 13.4 cents, or 0.134 cents. And now you're at, if you add that together, you're at $1.254. Times another 12%, now you're earning 15 cents. So we add that to the 1.254. All right, so the idea is each time we earn interest, we add it then to the principal, and we earn 12% on that greater amount every single time. And here's the 1.405. I've got a little bit of rounding difference than where they are at the end of year 3 here. Okay, so at the end of year 3, you had $1.254 plus the 0.151 cents. And that puts you at $1.404. And then that would be what would earn interest the next year. Okay, so I stop at year 5, and I do that for a reason. Okay, so get the idea here? If we looked at this in reverse, this is what's considered future value. Okay, now there's present value, there's future value, there's present value of 1, future value of 1, present value of an annuity, present value of an ordinary annuity, future value of an annuity, future value of an ordinary annuity, or annuity due. Sorry, I was saying the wrong thing. But the idea is that there's a whole bunch of these tables and a whole bunch of these calculations you can do. We're only focused on 2, the present value of 1 and the present value of an annuity. That's it. We're only looking at 2 sets of calculations in here. Okay, so getting back to my point. Let's say that I wanted to work this backwards. I want to know how much I need to put away today, which is the present value. How much do I need to put away today to have 1.574 in the future? Okay, so this is really my future value, and this dollar is my present value. Okay, so what if I didn't want to do all this times 12% stuff? But I knew that at the end of 5 years, I wanted to have it 1.574. Just play along for now. All right, if I want to have 1.574 in 4 years, how much do I need to put away today? So what I'm going to do is I'm going to take that future amount that I want to have, and I'm going to multiply it. And where am I going to get that number from? I'm going to get it from here. Oh, I can't get any bigger, I don't think. Let me see if I can do this. Oh, too far. That's my husband on the side there. Okay. Here we go. Okay, this is from your book. It's from the back of your book. And in the appendix, you have interest tables. All right, and this is the present value of 1. That's what we're looking at for right now. We'll deal with the annuity in a bit. I am going to look for 12% interest, which you see is not here, and a period of 5 years. We do the 5, but we don't have the interest, so it actually goes on to the next page. Here we go. So we have 12% interest, that's the interest rate, and we're looking at 5 years. When we come across, we have 0.56743. If I take 1.574, my future value, times, I'm making up numbers. Hang on a sec. Oh, 4 years. I was saying 5 years. Hang on. Go back. 4 years. 0.63552. 1.574 times 0.63552, because it'd be at the end of 4 years. At the end of 4 years is when you'd earn that. That's the beginning of year 5. If I multiply that times 4, I would have $1. Okay, so I basically use that table to go from my future value to my present value without doing all this work. Okay, so why is this anything? Let's look at it differently. Let's say I wanted to have $5,000 in 4 years. Here we go, a more realistic example. Maybe I know that I want to buy a car in a few years, and I want to have $5,000 put away. Interest rates are about 5%. How much do I need to put away today? 5,000 is my future value. I need to know the present value, so I'm going to go to the present value tables. And I'm going to look at 4 years and 5%. So get back to this table, because we've got 5% over here, and 4 years. The factor is 0.8227. So 5,000 times 0.8227 is $4,114.50. I would need to put away $4,114.50 wherever you're investing at a rate of 5%. Let's say you're putting the money in a bank in a CD. That's totally safe, right? And you're earning 5%. You're going to put away $4,114.50, and at the end of 4 years, you will have your $5,000. That's where this comes into play. Think about it. If you can start planning your future expenses, right? I know that I want to go to college. I know that I want to put away so much money. How much do I need to put away today to earn that interest and get it back later, the dollar amount that I want? Okay, so hopefully you see where that present value comes into play. All right, present value is the value today. All right, annuities. Annuities are multiple payments. It's a series of they have to be equal net cash flows at fixed time intervals. All right. Now here's the thing. Why would anybody want an annuity? Well, an annuity is a very typical way that people structure out payments, long-term payments. Let's say I wanted to put away money today. I'm working hard at my job, and I want to put away money now for when I retire, because I want in my retirement a certain amount of money to be paid out to me every year. That's an annuity. Okay, so the annuity piece comes in absolutely mostly with retirement. You're going to see that. But you're also going to see that with the lottery. The lottery is an annuity. And we'll get into the math on the lottery and a lottery example in just a minute on the next page. Okay, so here's our example. What if we wanted to put away money today and have that money pay out $100 per year for the next 5 years? How much do I need to put away today? If interest is, again, 12%, which is an unrealistic number. But anyway, so this is like an annuity. If you wanted to go, this is an annuity because it's equal payments. I'm looking for equal payouts for the next 5 years of $100 a year. What do I need to put away today? Now you may think, why would I want $100 every year for 5 years? Well, like I said with my retirement example, what if not $100? What if I wanted $100,000 a year? How much do I need to put away today to have $100,000 a year for the next, let's say, 20 years of my retirement? Okay, that's where the calculation's coming in. But we're keeping it simple with these numbers with $100. So what I could do is I could figure out every single year, if I put away money, what's that $100 worth to me a year from now, 2 years from now, 3 years from now, 4 years from now, 5 years from now. I could work my way backwards because that $100 per year is a future value. Same way as I did the other one. If this is my future value, what do I need to multiply it by to get to my present value? Okay, so here we go. Year 1. I want to pay out in year 1 of $100. I'm going to bring this down a little bit. I want to pay out at the end of year 1, year 2, year 3, year 4, year 5. I want $100 every year for the next 5 years. So what I'm going to do is I'm going to bring those dollars, those future dollars, back to the present value today. move myself over because I'm giving examples that are going off the screen. Okay, so that $100 a year from now, go back to our table, 12% and N is 1. Okay, 12% and N is 1, meaning period of time is 1. 0.892986. 2 years is going to be out 12%, 0.79719. 0.71178 for 3 years. Here's 4 years, here's 5 years. So I'm going to grab all of those numbers and I'm going to put them in here. I rounded them, but you see the idea. You're taking that first $100 that's going to be paid to you in a year, and I'm bringing it back to today's money, the present value. Basically, I'd need to put away $89.30 today to have $100 a year from now. Okay, what if it's 2 years? So it has 2 years worth of compounding interest. I would have grabbed it from the table, the 0.797, and I'd need to put away $79.70 this year to have $100 2 years from now. All right, 3 years from now, $71.20. 4 years from now, $63.60. 4 years from now, $56.70. So the idea is I'm bringing all of these present value, right, all these future values, future value a year from now, future value 2 years from now, 3 years from now, 4 years from now, 5 years from now, I'm bringing them all back to today's dollars. So the present value of the annuity is $360.50. What that tells me, if I put away $360.50 today, I will have the money to pull out $100 every year for the next 5 years. Okay, and like I said, you can see how that can easily factor into retirement planning. Alternatively, because it's an annuity, okay, this is where it gets fun. Well, I was going to say this is where it gets fun. Get excited, people. Because the amounts are equal, $100 every year for the next 5 years, I can cheat. It's not really cheating. It's more of a more efficient way of doing this. I can use the present value of an annuity table. Annuities are equal payments. With, again, my N is 5 because it's 5 years, and my I is 12% because that's the interest rate they gave me. So I'm going to come on down here and we're going to look at the other table. Present value of an ordinary annuity. And we're off the page. We'll go to the next page for 12%. 12%, 5 years, 3.605, I think I rounded. 3.605 times $100. I calculated $360.50. We multiply it times the amount. So what I'm saying is, it's easier. You don't have to go one by one for the years. If the dollar amounts are equal, you can use the present value of the annuity table to figure out what the present value is today of those $500 worth of annuity payments. All right. So I hope that this helped, because now we can start talking about present value. Net present value method. See you in a minute.